known as repeated multiplication. Now, this is going to come back again in this particular section. And you have to remember that the number, the factor being repeated, is called the base. And that's normally the bigger number. The superscript, which is the 4, is going to be considered the exponent, something you already know. Now, we have a table next, and this table some of you may have for homework. It is going to ask you to rewrite the expression in column 1 as repeated multiplication. And then they want you to write the final result, which is our third column, as an exponent. The object is to know the difference between column 2 and column 3. And what column 2 is what you're supposed to be thinking versus what you are supposed to be coming up with in the end. Now, let's take a look at the first row. Now notice this is 5 to the power of 3, 5 to the power of 4. Well, based upon repeated multiplication, these 3 are the first ones. The second 5 is the last 4 in our repeated multiplication. And then in the last column, how many 5s did I write in column 2? I wrote 7. That's why the result is going to be 5 to the 7th power. Now, this is where you have to understand what it's saying. Now, if you look at row 2, I have 3 times 5, 3 times 5. Okay. Now, notice I have 2, 3 times 5, 3 times 5. Well, this now means 3 to the power of 2 times 5 to the power of 2. We have 2 3s. We have 2 5s. That is repeated multiplication. So the result is 3 squared, 5 squared. Now, the next one is a fraction. Well, this is saying that we have 2/3 times 2/3. Well, when we write it in the third column, the numerator is going to have an exponent of 2. The denominator is having an exponent of 2. Okay. Now, next one. Now, this one you are going to write a couple of different ways. Notice that there is an exponent of 3 inside the parentheses. Well, this is saying 7 times 7 times 7. And then we have 2 of these 7 times 7 times 7. Okay. We have 3 7s because that's what's inside the parentheses. And then on the outside, we have 2. So that means I'm going to write the parentheses with 7 times 7 times 7 times 7, 7 times 7 times 7 times 7, which is going to give me how many 7s? 7, and I've got 6 of them. 3 in the first parentheses, 3 in the second. Now, this little bar in the middle for the last row means divide. So in the top, this will be 11 times 11 times 11 times 11 times 11. And then I have 11 times 11. Now this is a little different because in the last column, if you remember, all fractions have to be reduced. Well, one of the 11s in the numerator and one of the 11s in the denominator are going to cancel out. A second 11 is going to cancel out with another one left. Now, the result, notice I've gotten rid of the denominator 11s. So my final answer is going to be 11 cubed because these 11s cancel out, unlike the ones up above, because we're looking for the result. Well, the result comes after I reduce the fraction. Now, if you need this slide for your homework, you can either take a screenshot now, or you can actually take notes because you are going to see problems just like this, and you might even be lucky and get a table. Now, we are going to be talking about some rules, okay? There happens to be 7 of them, 7 rules. All of these rules you are going to have to know. Now, we're going to start out with rule number 1. Now, this is known as the power rule. Now, this is saying that when multiplying two numbers with the same base, keep the base, add the exponents. Well, if you'll notice in line number 1, I have x to the a, x to the b. My answer is to take that x and add a and b. But the second example, I happen to have numbers, and those numbers are not the same. Because remember, this rule says same bases. Well, the only bases that are the same are the letters. X to the A, X to the B. I have to take the 3 and the 4 and multiply that 3 and 4 because I'm still multiplying. Parentheses next to parentheses means multiply. So the numbers will multiply. But notice the X's. The A's are going to add together. Now, to give you another example, let's say I have 2x to the 4th, 3x cubed. This is saying take the 2, take the 3, multiply them together. Well, that will give me 6. But notice, how many x's do I have here? I have 4 of them. Remember, repeated multiplication is implied with that 4. And then in the second one, I have 3 more. Okay, 3 more here. Well, that means I have x to the 7th. This is my answer. Okay. Now, Second rule, rule number 2, is known as the power rule of quotients, and quotient a power rule of fractions. Now notice right here, inside a parentheses, I have a fraction. Now, the numerator is x, the denominator is y. This is why it's called the power rule of quotients, because my numerator and denominator are not the same number. But when raising the quotient to a power, and that power happens to be the power outside of the parentheses, I am basically having to know that my exponents are multiplying. And you're going to say, what? Well, this x has a power of 1 inside. A times 1 is how I get a to the first. Well, if I look at my y, inside the parentheses, I have a power of 1. The exponent way up here is multiplying by that 1 to give me x to the a. Now, let's give you an example. I have 2 thirds, and I'm putting out here a 3. Well, this is meaning 2 cubed over 3 cubed. This 2 has a power of 1. This 3 has a power of 1. The exponent on the outside is multiplying by that power of 1 because we're talking about a power rule. Okay, the power rule is dealing with the exponents. Notice, with exponents. And mathematicians don't like to write those number ones. Now, since we've evaluated exponents, we know that since we have a number here, 2 to the cube is 8. 3 to the cube is, in that case, it's not 9. It happens to be 27 because it's 3 times 3 times 3. This is my answer because I have numbers. Okay. Now, these are our first 2 rules. But remember, I have 7 of them. Okay. Well, here comes rule number 3. Okay. Now, this is called the product rule. Now, the last 2 were told as power rules. Now, earlier, or even before you were born, we used to call this rule the piggyback rule. And I still like that kind of name because if you look at the example down here, I have an a power inside the parentheses, and right on the outside, I have a b. Notice that the exponents are what we call piggyback. There's nothing between a and b, and they're in the exponent position. So with the power rule, I am multiplying. And let me give you a little example. I'm going to do this the long way. If you remember, I have 3 squared cubed. That's a 3. Let's see if I can make it better here. This is 3 squared with a 3. This is an exponent. This is an exponent. Now remember that table we did? That 3 on the outside is saying that I have 3 times 3, 3 times 3, 3 times 3. I have 2 3's in each parentheses. But how many 3's do I have? I have 3 to the 6th. I take this 2 and this 3 and I multiply. That's how I get 6. And what I do in here between my two hot pink, that's what I have to think. It's repeated multiplication simplified. Now, be very careful when you have a number. This 4 has a power of 1. I may not write that 1 all the time, but it's understood to be there because this A multiplies by the power of 1. Now X has a power of 1 and Y has a power of 1. The exponents are multiplying. And let's give you an example. I have 2x y. And I'm going to put a 3 out here. Okay. 2 has a power of 1. X has a power of 1. Y has a power of 1. The exponents are multiplying, which gives me 2 cubed x3 y3. These are multiplying each other. That's the product rule, or what we call piggyback. The piggyback is multiplying the exponents. Now, this rule is one that you have to watch. This is called Rule 4. Now, Rule 4 is known as the quotient rule. Now, this is where you have to watch. Okay, when dividing two numbers with the same base, notice same base. That's like the last row in the table that we started with. We're going to keep the base, and if the numerator exponent is greater than the denominator exponent, that's what you have to watch. If A is bigger than B, I'm going to keep that X, because notice X is the base of both A, the power of A, and the power of B, and I'm going to subtract them. And then I'm going to get XA minus B. Now let's give you an example. I have 5 to the 4th over 5 squared. Right away, this 5 is the same base. Notice that's what it said. Same base. Now I've got to watch. This exponent 4 is in the numerator. It is greater than the denominator exponent. So what I'm going to do is take the 5, which is the same base, but I'm going to take 4 and subtract 2, which gives me 5 squared. Okay. Rule number 4 is quotient. I have a fraction. The bases are the same. And notice there's no parentheses around here. Rule 2 had parentheses around the fraction. This has no parentheses. Now, Watch the difference between Rule 4 and Rule 5. Okay, this is also known as the quotient rule. But here is the little catch. When dividing two numbers, and again, same base, we're going to keep the base, but if the numerator exponent is smaller than the denominator, you are going to take the absolute value of the difference, and then you're going to create a fraction. Okay. Now, let me show you. This time, I have 5 to the power of 2, 5 to the power of 4. Now, my bases are the same. Notice they're the same. But my numerator exponent is smaller. Notice right here. This 2 is smaller than 4. Well, that means I'm creating this fraction. I'm going to put 1 in the numerator, and that's always going to be a 1. And then I'm going to take the 5 and take the absolute value of 2 minus 4, which means that I have 5 to the positive power of 2 in the bottom. I'm taking the absolute value. Remember what the bars mean? The bars mean that it's top, the 2, minus the 4, but because the numerator was smaller, it was a 2, I'm creating a fraction. And 1 is always in the numerator. Notice the difference between Rule 5 and Rule 4. 4, the numerator has a bigger exponent. Rule 5, the exponent in the numerator is smaller. Now, rule number 6. This is one you probably already know, but I like to tell you. And this is called the zero exponent rule. This x has a 0 power. Well, it always equals 1. Always. So if I have 5 to the 0, this has got to equal 1. If I have 1,000 to the 0 power, it equals 1. Now, something to be aware of. This number 1, in some cases, is not written but understood, that n to the 0 power is 1. Now, our last of 7 rules deals with fraction exponents. Oh, aren't you excited? These are going to be my fraction exponent rule. There we go. The fractional exponent rule. Now, this is what you're going to see. 1 divided by b is the exponent. Now, you need to rewrite this expression as what we call a root. Now, this is the catch. The denominator is going to be put as what we call an index. It is at the corner of this radical symbol. The number 1, which is my numerator, is the exponent of what we call the radicand, which is the number underneath the radical. So let me show you. If I have this problem, I have 2 to the, let's do 1/2. Okay. This is saying that I'm going to take a radical. Now, again, this 2 is supposed to be a number up here. Well, because the denominator is 2, that little yellow circle in front of the radical, I don't write, because a radical is dealing with 2. This 2 up here is my denominator. Radicals always begin with that 2 understood, and this will be 2 to the first power. This 2 is understood in root symbols. It always begins with a little 2. And you will find that Pearson doesn't write that little 2. And if you remember, there's certain numbers mathematicians don't write. In a root, we don't write the 2 up there at the top. But let's say I had the example 2, and I have 1/3. Okay. This 3 has to be written up here. And then 2 to the power of 1 goes underneath. This index is the denominator of the fraction exponent. And that's the key, the denominator. Now, I have several slides that I'm going to go through, and they are using all of these 7 rules. So when you do your homework, you got to know the rules, or at least have the rules ready when you do your homework so that you can figure them out. Now, this one. Okay. First off, I have a number 17, I have a number 2. I am going to multiply those numbers together, okay? So, step 1, multiply 17 and 2. This will give me 34. This is my step 1. Now, step 2. Since I have the same exponential base of x, I add the exponents of 2 and 5, which will give me x to the 7th power. That is this part. Okay, I add the exponents to get here, which is x to the 7th. Okay, I multiply the numbers. I add the exponents. This is your product rule. Now this one, okay, you got to be careful with this one. This has a 2 outside of parentheses, and right inside the parentheses, just on the other side of the parentheses, is a 4. Okay, now, first off, you have to know that this 4 has a power of 1. I don't write that 1, but it's understood. So step 1, using the power rule, or in this case, the piggyback rule. Okay, let's make sure here, because okay, yes. And this is known as your power rule. Okay. Okay. So power rule. Okay. We take the exponents and multiply them. Okay. Which means this 2 is multiplying by the 1. So this is 4 squared. Now this x is going to take the 4 that's behind it and multiply by the 2. Now, this 4 squared, you are going to need to know, because we did this in cycle 1. This is going to give me 16x to the 8. Okay. I am using, okay. Oh, I got to make sure I did this right. This, because see, I always forget, this is the power rule, and this we add, product rule we multiply. Okay. Sometimes I have to take a look back, okay, because I just do it without thinking what rule it is, because I know the rules. But in this case, we add the exponents, we multiply the exponents. This is another way of saying, and I prefer this one, the piggyback rule. That to me is how I learned it, was piggybacking. Okay. Now, let's look at the next one. Now, the next one you got to be careful with, because this has a -5. Okay, I'm going to do this one the long way. It's still the piggyback rule, but this is where you have to be careful. This is saying -5 times the power of 1 is giving me 2. 1 times 2, and then let's make that a good 2. And then this 2 is multiplying by the 3, which is giving me x cubed times 2. This is what you need to think when you have a negative number. Now notice it's inside the parentheses, which is why I keep -5 inside the parentheses. Well, this is very easy to do. We're going to get x to the positive 6th power. But this is where you're going to have to watch. This is a negative times a negative, which is going to give me a positive 25. That's why you have to recognize piggyback rule. This one is multiplying by 2, but it's saying I have 2 negative 5s. And 2 negative 5s is giving me a positive 25. Now, this one is easy. I got a 0 power. Now, this is going to give me a positive 1 response, because this -8 is inside the parentheses. Now, let's look at one a little differently. I'm going to take off this parentheses for -8. Notice here, okay. Problem E has no parentheses around the -8. It sits right behind the number 8. So this is where we have to be careful. An exponent pertains to only what's directly in front of it, which means that this negative sign has to remain. This is going to stay because 8 is the one that has the power of 0. The negative is not enclosed. This is a -8 to a power of 0, which means that a -8 to the power of 0 is -1. There is no parentheses here. So notice the difference. In problem D, we had -8 inside the parentheses. Notice it's inside this parentheses. But in E, there's no parentheses. D was a positive 1, but E is a -1. Okay. Now, the exponent of 0 only pertains to the number directly in front of it. It has no effect on the negative in front of 8. And this is got to be something you've got to remember. This piece right here, the exponent of 0 only pertains to the number directly in front of it. it has no effect on the negative in front of 8. And this little piece that I highlighted in yellow is going to drive some of you crazy, because you're not going to realize that that negative sign is not affected by the exponent. But as you look here, see that -5? That -5 is inside the parentheses. That's why it's -5 to the 2 power. This -8 is inside a parentheses. And if you'll notice, the exponent of 0 is directly behind the parentheses. So everything in the parentheses is to the 0 power. The exponent of 0 is, and this is the key, directly behind the parentheses, which means it's dealing what's in the parentheses. Unlike problem E, -8. Notice that negative is not. Okay. Notice right here. The 0 is right behind the 8. Now, this is our lovely fraction rule. Well, remember how this works? Okay. First off, the 3 has an exponent. The 6 has an exponent. Okay. We have a fraction. Well, this is going to become 3 squared x to the 8th. 6 squared, because remember, this 2 has got to deal with the exponents in the denominator, and this is x to the 6th. Well, now we're putting a lot of things together. Notice I have numbers. Well, I've got to rewrite those numbers as 3 squared is 9, 6 squared is 36. Now, that's the numbers. But don't forget, 9 36s have to be reduced, which is going to give me a 1, which is going to give me a 4. This is the fraction, the numbers. But look at my x's. I have x8, x2. Well, the 8, as you see, is bigger than the x to the 6th. Now, because this is bigger, the x is going at the top. Okay? Because remember, I don't have to create a fraction when the numerator is bigger, but I have to put a 2. This is the green part. Notice how I break it apart. X to the 8th, x to the 6th. This is bigger than the bottom, which means that I have x 8 minus 6. And remember, there's nothing down here, which is why it goes in the numerator of this fraction. Okay. So my answer is 1/4 x squared. Or sometimes Pearson, because remember, I don't like to write ones, they can also give you an answer that says x squared over 4. That's what this means. Because remember, I don't write ones. Okay. Okay. Here we go. Now, multiply the numbers, add the exponents. Multiply the numbers, add the exponents. Well, -3 times -6, okay? -3 times -6 is multiplying the numbers. This will give me a +18. Now, add the exponents. Well, notice they're all x's. I have a 2, I have a 5, I have a 2. This will give me x to the 9th power. And that's a 9. Okay? That's my answer. Now, number 2. Okay? Watch out for -2. Think. Parentheses. -2 to the 4th power. And piggyback the x to the power of 4 with 4. Okay, this is what you want to think. I have a -2 inside. This means that I have a -2 in parentheses to the power of 4. And that 4 comes from the 4 here. And then I'm multiplying x to the 4th to the 4th. Well, got to remember what this means. -2 times -2 times -2 times -2 is going to give me a +16 x to the 16. Piggyback rule. These two go together. Okay. And also remember, this -2 has a power of 1 as an exponent. This 4 is multiplying by 1, saying I have 4 -2's. 4 -2's gives me a +16. Okay. Now, quotient rule. Okay. But this has got a couple of little details. Okay. Notice here. In number 3, okay, you need to begin with the denominator and use your piggyback rule first. Well, this is going to give me x to the 15, and then piggyback rule. That's down here. This is x to the 6th. Now, notice right here, 15 is bigger than 6, which means I write the base of x and I subtract 15 minus 6, which gives me 9. This is then your quotient rule. That's this part. Once I get here, I got to use the piggyback rule first. Then I do my quotient rule. Well, number 4, notice how that I just flipped it. I have to do this first. You need to begin with the numerator this time and use your piggyback rule first. Okay, well, this is going to give me x to the 6th over x to the 15th. Okay, notice what happens here. 15 is in the bottom. Well, when 15 is in the bottom, 1 has got to go up here. X is still going to be here, but I'm taking the absolute value of 6 minus 15 in the denominator, which means I have 1 over x to the positive 9th power. Okay. These bars mean absolute value, which means I have to get a positive exponent, but it's in the bottom because 15 is bigger than 6. Okay. Now, this one. Okay. First, use your piggyback rule in the numerator. Okay. See this little 2? That 2 is saying that I'm taking the exponent of 3 inside the parentheses and I'm going 3 squared. X has got a power of 1, which is x squared, but y, 2 times 2 is 4. Now I'm going to put 3y cubed at the bottom. Well, notice right away I have a fraction. I have numbers, and I have a y at the top and a y at the bottom. But I still have that x. Well, I can't get rid of that x. That x is going to stay in the numerator. But I have 3 squared. That means 3 squared has got a power of 2. This 3 in the bottom has a power of 1. Where is the bigger 3? At the top. So that means it's 3 to minus 1 or 3 to the first. Now look at my y's. Where's the bigger y? At the top. So this is y, 4 minus 3 or 1. This is my answer, 3x squared y. And notice in this answer, I don't write the ones, but I got to know they're there. Okay? Okay. Now, in the next one, okay, use your piggyback rule on the second parentheses, not the first one. Okay, so that means I have 8yz. That's staying. This 2 is going to deal with everything inside this parentheses. Well, this 4 has a power of 1, which means I have 4 squared. This 2 is multiplying by the x2, which gives me x to the 4. This y2 inside is multiplying by the 2 outside, which gives me y to the 4th. Now don't forget, z has a power of 1, which means 1 times 2 is 2. Now, multiply. Okay. Now, once you've used the piggyback rule, okay, we've done the piggyback rule. We now multiply the numbers and add the exponents. Now you got to be careful here. This 8 is multiplying by 4 squared. That is saying 8 times 16. 8 times 16, which is going to give me, okay, 8 times 16 is 8, carry 4, 108. Okay. I have 108, or let's see, 16 times 8. Let's put this right. It's 128. I multiply the numbers. Now, if I look here, I have a yz. But do you notice that I have an xyz? X to the 4th is going here. Now the y behind the 8 has a power of 1. That means this is y to the 5th power. And how many z's do I have? I have z cubed. So my answer is 128 in this case. Ooh, don't forget, oh, get me. I forgot to put an X right here. I forgot. This is, okay, come on. This should have been 8xy. I forgot to write this x, which means that this x is not a 4, but it is a 5. Yeah, see, I got to see all the numbers. because this behind the 8 I have an X. Well, I forgot to write it in blue down here. I just wrote YZ. So I got to remember that behind the 8 is an X. Behind the 4 squared was an X. That gave me 5 X's. Okay. Now, let's look at this one. Okay. Fraction exponents. Now, this too is understood to be the index right here. And therefore, I have 36 to the power of 1. Well, you now need to remember that the square root of 36 is 6. This symbol is square root. And this square is the number 2, because that's what the symbol means. Square root. The denominator of my fraction has a 2. Now, number 7. Okay. Watch what I have here. I have a 3. Okay. Well, this, when I make my root, this is called the cube root. Now, negative 27 to the power of 1 goes here. Now, the cube root of negative 27 is going to give me negative 3. Now, why is it giving me a negative 3? Because you see this little 3? It's saying I want 3 numbers that multiply together to give me negative 27. But they all must be the same number, which is negative 3 times negative 3 times negative 3. One of these 3's is my root. One of these 3's is my answer. Now, just as I did 36, how did I get 6? Well, think about it. I need a number times itself. 6 times 6. But my root is just one number. My root is 6. Okay. Now, we're going to get into interesting things. Okay. First off, you have 2 piggyback parts. This part, and then you have this part. Okay. First, use your piggyback rule for the first term, and then use your piggyback rule for the second term. The first term is going to be my green term. My second term is my yellow term. Well, the green term is going to go right here. Okay. This will give me 5 times 2, or what I'm getting is x to the 10th power. Okay. I'm still multiplying. Why am I multiplying? Because there's no space between here. And then I'm taking my yellow term, and I'm going to put it right here. This is going to give me x to the 16th. This is taking my piggyback rule for the first term, which was the green one, and then the second one, which is the yellow one. Now, to finish, add the exponents of the same base of x. Well, that means my answer here is x to the 26th power, same base. I have two x's, an x to the 10th, an x to the 16th. Okay. Now, last one. Same thing as before. Use your piggyback rule on the first term, and then use your piggyback rule on the second term. Note, watch out for these negative signs. Okay, this is what makes this one a little different. Now again, this is my first term. This is my second term. Now, you gotta be careful. Now we're going to do the green over here, right here. Well, this is why I'm saying watch out for the negative signs. Now inside the parentheses, I have a negative r cubed with a 5 on the outside. I have s to the first power to the 5. Okay. Now, gotta be careful. This is saying I have 15 negative signs. 15 negative signs. Well, 15 is odd, so my green, which I'm going to write here, is going to give me a negative r to the 15th, s to the 15th. This is my first term. This is where you have to be careful. I have negative, negative, negative. That negative r shows up 3 times. That's a negative sign. I have 5 negatives, which is why I'm getting a negative r to the 15th power. Now, gotta be careful with the next one, which is the yellow one. Now, we're going to do the yellow down here. Well, this is where you have to realize that this is negative r to the 4th power to the power of 4. This is s to the power of 4, 4. Now, this one, 4 times 4 is a positive, because if you think negative 4 times negative 4 times negative 4 times negative 4 is giving you a positive 4. A positive 4 to the 4th, this will give me r positive times 16 s to the 16. Odd power, I'm keeping that negative sign. And even power, I'm going to get rid of my negative sign. Now, to finish, add the exponents. But remember, a negative times a positive is negative. And you're going to say, well, where did that come from? Because remember, mathematicians don't like to write this lovely number 1. This -1 and this +1 is where the -1 comes in. This will give me r to the 31st power, s to the 31st power. And remember, mathematicians don't like to write the number 1. So my answer is negative r 31st s to the 31st. This is my answer with this 1 understood. Okay? Now, we have 4 more slides, or a couple more slides, and we're using some formulas. Formulas that you should be familiar with, and they are all using exponents. We have formulas for circles. We have formulas for squares. We have formulas for rectangles. Now, you gotta watch here. The A represents area. Now, this C is known as the perimeter or circumference of a circle. Circle's round. So using the word perimeter, which is the distance around, is replaced by the word circumference, which is around the circle. So when you see P, that's perimeter. Now, you either know the formulas or you have to look back at this. Now, they're going to tell you that what figure that you have in the story problem. Now, it's asking you to find the perimeter, and it's asking you to find the area. Well, for a rectangle, the perimeter is 4.5 centimeters plus 0.6 centimeters plus 4.5 centimeters plus 0.6 centimeters. Okay. Now, before I forget, this symbol means by in math. It's not a multiply sign. It's 4.5 by 0.6, which is saying that you have 4.5 centimeters here, 0.6 centimeters here, 4.5 centimeters here, 0.6 centimeters here. Now, when you add all of the numbers, 4.5, 0.6, 4.5, 0.6, you are going to come up with the number 10.2, and it's centimeters. We're adding. Okay, notice we're adding. But when we have area is 4.5 centimeters times 0.6 centimeters. Now, this is where you get to see exponents in motion. 4.5 times 6. We multiply the numbers. We are going to get 27.0. Now, do you see that I have centimeters and centimeters? I've got two of them, and I am multiplying, which means that my answer is going to be centimeters squared. This has a little 2 because I'm multiplying the numbers. If I multiply the numbers, I have to add the exponents. Well, remember, centimeters has a power of 1 in both places. How many centimeters do I have? That's where the 2 comes from. Okay. Now, here we go. This story problem, you have to know what the words mean. Find the amount of edging needed for a rectangular deck. Now, edging goes around the deck, which means we want the perimeter of the deck. The amount of edging is the perimeter around the deck. So therefore, perimeter is going to be equal to 76 centimeters plus 46 centimeters plus 76 centimeters plus 46 centimeters. And if I add them all together, I am going to get 122 centimeters. Notice I'm adding. When I add, I keep the units of centimeters. It's not squared, it's centimeters. Okay. Okay. Oh, let's make sure I added them right. 76 plus. Oop. 122 are just these two. So 122 plus 122 centimeters gives me 244 centimeters. That's my full length. I forgot that I didn't multiply both of them. I didn't add all 4 numbers. I only added 2 of them in my head. Bad me. Gotta add them all. Okay. Now, this one. Okay, this is a formula that you have to know. Okay, perimeter is distance around. Now, the area has a formula. Now, your book is not going to give it to you because they believe that you know it. Now, the perimeter is very easy. In a triangle, it's the distance around. So when I talk about the perimeter, it is 15, 13, 14. I'm going to put them in columns. That way I don't forget to add them all. And this will give me 242, and this is meters. Now, the area is a formula of 1/2 the base times the height. Now the height is this thing in the middle. So this is area is equal to 1/2 14 meters times 12 meters. Multiply the numbers. This 1/2 times 12 times, or 1/2 times 14 times 12 is going to give me 84. But be careful. We're multiplying meters times meters, which means my answer is meters squared. Okay. I have got to multiply 1/2 times 14 times 12. Multiply the numbers, and then we add the exponents of meter and meter. 1 plus 1 is 2. Now, circle. Okay. Now, first off, watch very carefully when you deal with a circle. They're talking about circumference. They are talking about area. But in the formula, they are wanting you to use 3.14 for pi. Okay. Well, in this case, we have a diameter. Well, if you remember the formula, circumference is equal to the diameter times pi. Diameter times pi. Well, if the diameter is 5 and 3.14 is pi, when I multiply these two numbers together, 5 times 3.14, this will give me 15.7 meters. And the reason is 5 is the only thing that has meters. Okay. Now, area. Okay, this is a totally different ball game. Area is equal to pi r squared. R is radius. And that means this 5 has to be divided by 2. A diameter is twice a radius, or a radius is half the diameter. Radius is half the diameter in the formula. Now, you can take your calculator and do 5 divided by 2. And when you write this, now remember, we have 2 of them, which means this is 3.14 times 2.5 meters times 2.5 meters. I need 2 of them. Okay, that's a point. Well, if I take 3.14 times 2.5 times 2.5, I am going to get 19.625. But this time you got to be careful. Meters times meters, which means that this is meters squared. Now, the last couple of slides, we are going to give you some formulas. these formulas you have to use, and the formulas can change from person to person doing Pearson. So be aware that this is saying use the formula V equals pi r squared h. Now, find the volume. Volume is the V of a cylinder whose radius is 2 centimeters and height of 1 centimeter. Now find an approximate answer by using 3.14 for pi, but here's the catch. Round to the nearest tenth. And then we got to include the units. Okay, what does this mean? This means V equals, now the pi is 3.14. Now, this radius has 2 of them. I like to write it 2 times 2. And my height is 1. This little r, because it has 2, I write it out just to make sure that I do not make a mistake. Now, when I get done, this will give me, in this case, 12.56. Now, this is centimeters, this is centimeters, this is centimeters. Okay? Centimeters, centimeters, centimeters. How many do I have? I have 3 of them. Because the 2 is centimeters and the height is centimeters, and I got 2 2's, so that's centimeters times centimeters times centimeters. Now, this is where you got to watch your answer. We got 12.56, but that's not what they're going to ask you for. My answer is going to be 12.6 centimeters cubed. This is the answer they want because we're rounding to the nearest tenth. Tenth is 1 decimal place. Okay. Now, here comes another one. This formula is a little longer. Now notice right here, this R has a 2. Okay. Now, this is how the thing is going to change a little bit. And that's why you're going to need a pi key on your calculator. You can't use 3.14 here, because if you use 3.14, you can be slightly off in an answer. Now, it says, find the surface area. Surface area happens to be this SA. That's what surface area means. Of an aluminum can that is 6 inches tall. Now, it has a diameter of 2.5. Now, remember, R equals radius, and the radius is half the diameter. So you got to be careful here. Okay. Keep pi in the calculation until the last step. Then use a calculator at the end to estimate the answer to the, here we go, nearest square inch. This means whole number. Okay. Now, we got to come here. The diameter was equal to 2.5. The radius is going to take 2.5 and divide it by 2. That's the first thing we're going to do, which means when I see R, I am going to put 1.25. So here we go. Surface area. Equals 2. Now we're going to keep the pi here for the moment, and we're going to write 1.25 times 1.25. Now I'm going to come down here, plus 2 times pi times 1.25. And remember, height is 6. Now, to begin, take all of the numbers. The 2, 1.25, and 1.25, and multiply them together. Now, this will give me 3.125 pi. These are all of the yellow numbers. And then I'm going to add all of these green numbers. Okay. I am adding all of the green numbers. Well, I'm multiplying, which is 2 times 1.25 times 6, which is going to give me 15 pi. Well, add 15 plus 3.125, combine like terms. This is going to give me 18.125 pi. Now, you gotta then take and use your pi key on your calculator. So you're multiplying 18.25 times pi. Well, this will give me 56.941. But I need a whole number. This is going to round to 57. But what's my increment? Well, if you notice, 2 is part of the formula. I have 2 yellow 1.25s, and I have 2 1.25 times 6, which means that this is inches squared. This inch times inch, this inch times inch. These 2's don't have any units after them. This is my answer. Okay. Now, last slide. Now, unfortunately, this is one that your book believes that you know. This is called the volume and surface area of a cube. Now, I don't agree with the fact that they're not going to give you a whole lot, but they do. They are telling you the volume of the cube is VS3 to the power of 3. So that means my volume is going to be 4 centimeters cubed. This is my S, or my side. Now this is going to give me piggyback rule. 4 cubed centimeters cubed, which is 64 centimeters cubed. Now, they then want surface area. Well, surface area, now it's 6 times 4 centimeters times 4 centimeters. Multiply the numbers. This 6 times 4 times 4 is going to give me 96 centimeters squared. Yeah, I didn't think they gave you the formulas with this one, but they do. Thank you, thank you, thank you. These are my formulas. I just got to know how to use them. Now, with that said, this ends this section of 2.3. Yay!